Hi, this presentation is about solving problems with acceleration. You have to know the equations from Chapter 2, and now we're going to add 4 more equations of motions. These are equations of motion. These are called kinematics equations. Kinematics is the study of how things move. In order to solve problems, you need kind of a step-by-step method that you always use. And the first thing you want to do is, while you're reading the problem, write down what's given in the problem and what's being asked for. Then you have to choose an equation. And as you can see, we have now 5 equations, including the one from Chapter 2. And so we're going to have to make some choices about what equations that we use. So you pick an equation that has the ones that you've written down as givens and what you're being asked to find and nothing else. Solve the equation for the missing variable. Get in the habit of rearranging the equation so that what you're looking for is by itself. Don't just plug numbers in. Wait until you have solved for the missing variable and then plug your numbers in. And make sure that all of your answers have units on them. The equation that we learned in Chapter 2, this one, average velocity is displacement over time. This is average velocity, not instantaneous velocity. In Chapter 2, the objects were typically traveling with a constant velocity, and so distance over time was how we found it. In this chapter, things are changing their speed, they're accelerating, and you cannot use this equation to find an instantaneous velocity if the object is accelerating. So we won't use this equation very much in this chapter. It'll mainly be these. An acceleration is a change in velocity divided by time. Now, because of the constraints of this program, I couldn't write delta, but typically we would write acceleration equals delta v over delta t. So that's a final velocity minus an initial velocity over that time interval. This equation, we'll call these equations 1, 2, 3, and 4. Equation 2 is really the first equation rearranged to solve for final velocity. Often, you'll be given the initial velocity, your acceleration and time, and asked to find how fast something's going. And so it's just this equation. Acceleration is final velocity minus initial velocity over time, solved for final velocity. So really, those two are the same equation. This equation, final position equals initial position plus initial velocity times time plus 0.5 at squared. And usually we write that last part right there as 1/2 at squared. It really doesn't matter. You'll see me, if I help you with problems, I'll write it this way just out of habit. And in most books you'll see it this way, but again, this program, if I wrote 1/2, it made it look like it was 1/2 at squared, like everything was in the denominator. So writing it this way was a little bit more clear. And then the last equation, the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the displacement. Okay, so 4 equations that we're going to have to use, not just one. Let's do some practice. Find the uniform acceleration that causes a car's velocity to change from 32 meters per second to 96 in 8 seconds. So what we have here is an initial velocity, we have a final velocity, and we have a time, and we're looking for acceleration. So you want to find in this list of equations one that has acceleration, initial and final velocity, and time. And that would just be the definition of acceleration. Acceleration equals the change in velocity divided by the time it takes to change. So we have the equation arranged so that what we're looking for is by itself. Change in velocity is final minus initial, so it's 96 minus 32 over, and the time is 8. I've got my handy dandy calculator. 96 minus 32 equals 64 over 8. And I can do that in my head. That's 8, and the units are meters per second squared. A car with velocity of 22 meters per second is accelerated uniformly. I go ahead and label this as my initial velocity. Is accelerated uniformly at a rate of 1.6 meters per second squared. That's my acceleration. For 6.8 seconds, and obviously that's my time. What's the final velocity? So I need, again, initial and final velocity, time, and acceleration to be in my equation. It wouldn't make any sense to pull an equation like one of these last two that has distance in it because I don't have a distance given or asked for in this problem. So I'm going to use the rearranged version of this formula. VF equals VI plus AT. Initial velocity is 22. Acceleration is 1.6. And the time is 6.8. Pull out my calculator. 1.6 times 6.8 equals 10.88. And 22 plus 10.88 would be 32.88 meters per second. Make sure that you put your units on your answer. Okay, well those are the simplest equations, and they're kind of the same one. Let's try something a little harder. Same equations I think we're going to be using on this one, but what happens when something slows down, when the velocity is positive and the acceleration is negative? Let's do some negative acceleration calculations. A car slows from 30, that's your initial velocity, to 15, that's final. In 12 seconds, obviously, that's your time. Find the acceleration. So we're going to use acceleration is change in velocity over time. So VF minus VI. So see 15 minus 30. Do you see how a negative sign is going to get introduced? Divided by 12. 15 minus 30 is negative 15. Divided by 12. And 15 divided by 12 is 1.25. So negative 1.25, put your units on there, meters per second squared. A ball is thrown into the air with an initial speed of 20 meters per second. It experiences an acceleration of negative 10 meters per second squared. How long will it take, looking for t, this is acceleration, how long will it take the ball to reach the peak of its path? Now, what does it take the ball to reach the peak of its path? What does it mean when you throw a ball into the air and it reaches the peak of its path? Well, it stops. It goes up and it stops and it comes back down. So the velocity at the peak of the path is 0. So we actually are given, not explicitly, but we are given the final velocity. So if we're going to look for t, well, acceleration is change in velocity over time. If I want to solve for time, I'm going to multiply both sides by time. And I've got acceleration times time equals a change in velocity. Well, I don't want acceleration on this side, so I'm going to divide both sides by the acceleration. And that gives me time equals change in velocity over acceleration. And the change in velocity, remember it's final minus initial, so 0 minus 20 over, the acceleration is negative 10. And negative 20 over negative 10 is positive 2 seconds. Time will always be positive. If you solve for a time and you get a negative value, then you've done something wrong. So look back through your work and see if you can't find out where you messed the signs up.